Problem 27. Suppose x has the cumulative distribution function capital F of x of 1 over 1 plus e to the minus x. What is the density function? Sample exam 2 of 8, problem number 27, asked to find the density function, and we find that by taking the derivative of the cumulative distribution function, which is this, which differentiates to that, and there's our density. Problem 28. Let alpha be the significance level of a hypothesis test. Why would one choose a small value of x? Number 28. Why would one choose a small alpha? That's to make rejecting the null, given that H1 is true, small. So to reduce the type 1 error. Problem number 29. A continuous random variable x has the density function of 2x between 0 and 1/2 and 4/3 minus 2/3 x between 1/2 and 2. What is the median? Number 29. We want to find the median of the function f of x. And to find the median, we want it from its lower limit, which is 0 to some m equal to 1/2. So f of x can be really written in two pieces. It's one function from 0 to 1/2 and another function from 0 to 2. And remember that. So it's from 2 or less, which will play a part in a minute. So let's look at the first piece. Let's integrate the function 2x over the whole region 0 to minus 1/2. And if we integrate that, we get 1/4. So now when we integrate f of x, the whole first piece is 1/4. We still want it to be 1/2, which is our median, but now we're going from 1/2 to m, where m is less than 2. And this is the function over 1/2 to 2. We integrate it from 1/2 to m. We get this. Simplify, we get this, which is quadratic in m. So we can solve that for m. So m is 2 plus radical 6 over 2, or 2 minus radical 6 over 2. But notice that our region is less than 2, so m has to be less than 2. And if we take the positive part of this, it goes beyond 2, so that can't be the median. So the median is 2 minus radical 6 over 2. Problem 30. If x has a uniform distribution on the interval from 0 to 10, then what is the probability of x plus 10 over x greater than 7? Problem 30 is we're on a uniform distribution from 0 to 10, which is this, and we're asked to find this probability. Well, if we multiply it through by x, we get this, and then take this piece to the other side, so we get a quadratic that has to be greater than 0. Well, this quadratic can be factored, and that has to be greater than 0. So in order for two numbers to be greater than 0, their product, they either have to be both positive or both negative to be greater than 0. So there's two cases here where they're both positive, which simplifies to x greater than 5, or they have to both be negative, which then simplifies to x less than or equal to 2. So the probability we're trying to find is the probability that x is greater than or equal to 5, or plus x is less than or equal to 2. And those two probabilities in a uniform distribution can be calculated like this, and the answer is 7/10. Problem 31. suppose x and y have a bivariate normal distribution with common means equal to 0, common variances equal to 1, and correlation rho. What is the value of a constant k such that x and y minus kx are independent? So number 31, we want to find a constant k such that x and x minus kx are independent. But before we start, an important note in this problem is that we're dealing with normal random variables, or bivariate normal random variables. So when the data are normal, the fact that they're independent and they're uncorrelated are the same thing. One implies the other. And that's not the case for other distributions. So we want to find that they're uncorrelated. So the covariance is 0. Well, the formulas for the covariance tell us we can take x covariate with this minus k times the covariate of x and x. Well, in order for this to be 0, we can solve for k here. But a quick note on the covariance of x and y. So the covariance of x and y divided by the square root of the variances, that's correlation. But in this case, it says the standard deviations or the variances are 1. So the covariance is just the correlation. So rho can be replaced for this. And the covariance of x and x is the same as the variance of x and x. So that's 1. So this equation comes to here. Well, then that simplifies to k is equal to rho. Problem 32. Consider independent success-failure trials with success probability p. Let x be the number of trials up to and including the second failure. This is for k equal to 2, 3, 4, etc. What is the probability of x equal to k? Here we want to find the density of, or the probability that we observe 2 failures. And we want to find the probability that we observe 2 failures in k trials. So if we think about this, there's going to be k trials total, with the last one being a failure. And the first failure can happen anywhere within the first k minus 1 failures. Okay? So the number of ways that we can mix this one failure into these k minus 1 trials is k minus 1 choose k minus 2 possibilities. And in here, there's going to be k minus 2 successes. There's going to be 1 failure. So this piece is this first one. And then we have to end on a failure, which is 1 minus p. Well, then this simplifies to this. Number 33. What is the 87.5 percentile for the distribution with density function of f of x equal to 1/2 e to the minus absolute value of x? Number 33, we want to find the 87.5 percentile of a given function. So this is the function that they give in the problem. F of x is equal to 1/2 e to the minus absolute value of x. So if we think about this function, we want e to the minus something, because that's always going to be positive. But if we think about it, when x is less than 0, that's a negative. So really this is a negative x when we're talking about negative numbers. So this function is this when we're in the negatives. And then when we're in the positive x's, then it's 1/2 e to the minus x. So to find the percentile, we have to consider both cases. Now, we should be able to just look at this and know that it's symmetric about 0. So that if we want to find the 87.5th percentile, we know that we have to go past 0, because from 0 below is going to be 1/2. But let's show that. Probably that x is less than 0. We integrate from negative infinity to 0 of this function, and which integrates to this. Plug in the range or the values, we get 1/2. So to find the 87.5th percentile, or 0.875, we want to find x less than p such that is the case. Well, the probability that x is less than p is this. And remember, we have to break up f of x so the probability that x is less than 0 plus the probability that it's between 0 and p, where p is the 87th percentile. So we have 1/2, which is this probability that we're negative, plus the probability from 0 to p, which is this, and that's that function. Integrate this, and we get this piece. Remember, the half is carried over. This, plug in the values, we get these. We can combine the 1/2s to 1. And now this is negative, so we could take it to the other side, but then bring the 0.875 to this side, which then implies we have this relationship. Multiply both sides by 2 to get e to the 1/2. Notice that the 0.25 is 1/4. So when we take the natural log of both sides, we get minus p is equal to the natural log of 1/4. We take the negative of both sides, so we take the negative here in front, but that negative can be raised to this power, and 1/4 to the -1, that take the reciprocal of it, so we just get the log of 4. Problem 34. Suppose a random sample of size n equal to 17 is taken from a normal distribution having mean, mu, and variance sigma squared. To test the null hypothesis that the mean is equal to 0 against the alternative that the mean is equal to -1. If the critical region is given by x bar less than 1 minus 1, what is the power of the test? Now, problem 34, it asks us to find the power of the test. Well, it gives the critical region of x bar less than -1. So to transform this, and x is normally distributed, so we subtract the mean from both sides, which is -1, divided by the standard deviation, which is sigma over the square root of 17. Well, this is a z, it's a standard normal, and this piece is always 0 no matter what the true standard deviation is. So this is 0. So the probability that z is less than 0 is 0.5.